enormous interest now in what the effects of lifestyle interventions such as exercise and diet may have on the risk for Alzheimer's disease or on brain health and function in general. In animal models, mouse models of Alzheimer's disease, for example, there is recent evidence suggesting that exercise and diet can modify the progression of the lesions of Alzheimer's disease in these animal models.
One of the breakthroughs in the field is to be able to have a mouse model of Alzheimer's disease called a transgenic mouse. And it simulates a lot of the pathology that develops in the human brain with Alzheimer's disease. I had this idea that maybe a growth factor or a neurotrophic factor, which is kind of a nutrient or a fertilizer to neurons, which also makes them smarter, might be naturally increased with exercise. We take two groups. One is just sort of in their cage and don't have access to a sort of a running gym. And the others get in their running wheels at night and they exercise. In order to test their learning, we basically take the two groups and put them in this Morris water maze. They are put in the tank and they don't like the water, and what they have to do is they have to find a little platform that's sort of below the surface. It's really kind of equivalent to finding your car in a parking lot at an airport when you can't really see it, but you sort of have to learn from the cues around the airport of where you parked.
Sedentary animal still has not located the platform at this point.
Alright.
We find consistently that the animals that have exercised are able to learn faster and better than the animals that haven't exercised.
Alright.
Yay!
Did it?
We looked at their brain, and lo and behold, BDNF was increased in the part of the brain that is controlling thinking and learning and is vulnerable to Alzheimer's disease. And all I could say to myself, and my students would say, holy camoli, that is so smart. The brain knew something and how to look out for itself that we had no idea about. So it kind of has a self-preservation mechanism that also makes it smarter and to learn better. Certainly in animal models, there's no question about it. Exercise can induce growth factors in the brain. It can help build new neurons into the circuits. It can build synapses, improve learning, and it can basically improve vascular function. Oh my gosh, what drug will do that? Nothing. And, it's simple exercise. You can identify new neurons by stains, that highlight the new cells that are just born. And when you look, there's fewer of them in the animals that are just sedentary than in the exercised animals. And it's really quite dramatic. So exercise actually increases the number of new neurons that can be added to the hippocampus. The exciting conclusion is that when we tested the animals that develop Alzheimer's disease in the brain, they benefit as well from exercise, just like the wild type. So they learn faster and better, which is very encouraging because it means that may help delay the onset of Alzheimer's disease from the experience of exercise. If you asked somebody 10 years ago, how are you going to fix brain aging or what are you going to do? They would have told you it's a medication. Now we know there's great promise in terms of behavioral interventions that can be adjuncts to medications and good health policy.